Once the physical protection design has been evaluated against the objectives, the result will either be that the design meets the desired criteria, or that vulnerabilities exist that must be addressed through redesigning the physical protection system. As a result, the security analyst must determine what is the most effective way to upgrade the system, in terms of resources and the improvement in the security system's effectiveness. Upgrade analysis is required when the physical protection system design analysis shows that performance does not meet the objectives determined at the beginning of the depot process. As we have discussed, there are a number of ways that the physical protection system could be upgraded. These can include improving detection through installing new or better sensors or improving communication and assessment systems. Delay barriers can be added or reinforced. The response force can be improved through a variety of ways, including adding more guards, upgrading equipment, adding hardened defensive positions, decreasing response time, and changing response procedures. Upgrades could also include changes not directly related to the physical protection system components. These may include things like decreasing the amount of material on site or in use during operations, or enhancing material access procedures, for example, installing the two-person rule. Upgrades could also include improving the accountancy system or adding continual observation of materials when they are not in storage. When considering upgrades, the analyst will look to see if the system is balanced and if it displays protection in depth. A balanced system means that the security elements on each layer or sets of layers have similar characteristics. For example, if a building has a structurally reinforced wall, a high security door, and a standard window, the window represents a significant delay imbalance on the layer. Protection in depth is also important. It means that the success of the security system does not rely on a single or small number of security elements. Without protection in depth, the system effectiveness may be highly sensitive to the successful operation of a small number of elements, and it is better to have security parameters spread out to provide confidence in the system. It would typically be more effective to install upgrades that improve the performance against many different pathways or scenarios. For example, adding delay at or close to the target affects every pathway that goes to that target. Also, upgrading the response force can potentially affect all pathways and multiple scenarios. Upgrade analysis will look at a number of different upgrade options and analyze how well they improve the system effectiveness as well as their associated cost. The options can then be evaluated by plotting both variables as shown here.